So next up, we will have Tarun talking about autonomous AI agents for dummies. He's a special guest, of course, but he actually traveled from India all the way to come talk to you all. So please give a round of applause to Tarun.
Hello, everyone. Okay, so meanwhile, let's have a quick activity. Can every one of you stand up just for a minute? Let's have few quick questions. Just for a minute, not more than that. Just a minute. Okay, you can stand up for a minute. Okay. All right, so I'll just ask few questions on what tools you are using in AI so that it will give me a clarity on giving examples, right? So how many of you have heard of Hugging Face? Can sit down. Or open source LLMs. Hugging Face. Okay, so there are few people who knows it. All right. Oh no, there are few more questions. Okay, so how many of you have heard of a concept called retrieval augmented generation? Can sit down. Okay. How many of you have used ChatGPT? Can sit down. Okay, so I guess ChatGPT, the version is different, right? Okay, if you have heard of LLMs, you can sit down. Large language models. Have you heard of large language models, LLMs?
I think most of them are actually thorough.
Okay.
Stand up, please.
How many of you don't know what is LLMs? Is there anyone? Cool, all right. So I'll start with my introduction. Okay, my slides are here. So my name is Tarun Jain. I work as a data scientist at a startup called AI Planet. It's a Belgium-based AI startup. And I'm also a Google developer expert in AI/ML, where I talk about Gemini and other AI tools. And I was part of Google Summer of Code, which is an open source program by Google. And I was part of Redden Labs and CA Microscope for 2 consecutive years. So yeah, in my free time, I watch anime and I read manga. And apart from that, I also code.
Okay, say it soon.
Thank you. Okay, so in February 2023, there was a tweet by Andrew Ng, the founder of Deep Learning AI and also Coursera. So the tweet was, AI agentic workflows will drive massive AI progress this year. Ever since this tweet came out, there has been massive progress in AI agents, right? So agents basically is like you're building humans, right? This is where there are multiple frameworks, and one framework that we will talk in our today's session will be on PyData. So PyData, it is an open source, it is a complete open source framework which can help you build agent and also ship it. The only 3 things that you need to keep in mind is you need to use an LLM, you need to use a tool, and you need to give a memory. That's it. Once you give these 3 parameters, you have an agent which will imitate a human. So you have few more examples. Since it's completely GitHub open source, you can scan the QR code. You will get a few examples like cookbooks, where you can experiment with different kind of agents. You have finance agent, web agent, and other kind of agents. And meanwhile, since it's open source, you can also start it. Right, so let's build everything from scratch. Let's understand what is an agent and how can it replace a human, right? We'll start with the step 1. In step 1, whenever we humans, we build something, we are given a task. Hey, this is your task, you need to execute it, right? So once we have the task, we divide that into multiple teams. We have designing team, we have coding team, we have testing team, then you have documenting team. So once the task is given, the first task is given to the designing team so that they will prototype your solution. They will think what features are we supposed to build, whether this is a front-end feature, whether it is a back-end feature, whether it is a AI feature. So the designing team will have the overall idea of your application that, hey, this is the product and this is what you need to build. So once designer have that perspective, you are giving that entire designs to the developer so that he can write the code. This is what we humans do, right? We design the solution, we code them, and then we give it to the testing team so that they can test all the features. And once they tell, okay, this is good, let's document it. So this is a typical process on how we build applications. And now let's talk in terms of agents. How do you perceive things? What are the examples? So let's take an example. What you need to do is you need to predict what will happen tomorrow, whether it will rain or not. And based on that, you need to make a decision whether you need to take an umbrella or not. So this is a simple problem statement. So based on this, the first thing is you will have a perseverance. Okay, so I need to decide whether I need to take an umbrella or not. So this is where you will go to Weather API or Google or any web browsers that you are using, right? So based on that, you will get the weather report. Okay, whether is it gonna rain tomorrow? And you will see the weather. Okay, it's 28 degrees Celsius. And then you will make a decision. Now that you have these two components, one is your perseverance and the second thing is a tool. In tools, you have your weather API. Based on these two, you will make a decision. Okay, should I take the umbrella or not? So whenever you are making a decision, your brains comes into the picture. The brain is what makes that particular decision to happen. So this is complete idea of agent. You have the tools from where you are getting the context. You have the perseverance, and then you have a brain which will make the decision for you. And if you want to go step by step, let's talk about the actual components to build an agent from scratch, right? So we'll take an example of Copilot. Everyone knows what is Copilot? Okay, if someone who doesn't know what Copilot is, it's like whenever you want to write a code, you just go to Copilot and say, hey, this is a bug, can you fix it? And it will fix it for you. So it is writing code for you, right? How is it able to write the code? You're feeding in some context. Hey, this is my code base, can you understand it? So this is a tool. Code interpreter is a tool. Same example of Weather API. Where are you getting the data from? You're getting the data from web browser. Search is a tool, right? So we have multiple varieties of tools which is available in our hand, and we have that flexibility. Whenever I need Copilot, I'll go to code interpreter. When I want to do Weather API, I'll go to web search. So we have flexibility when it comes to human. This is what we need to provide to agent as well. Hey, this is the set of tools that you need, and you have the flexibility to pick anything that you need. Now that flexibility we are giving in terms of action. So first we list down all the tools, then we have an action component which will take the action of what tools it needs to pick. So we humans pick tools, right? So based on this tool, we are taking the action. So these are the two components. The next thing is the very important part. In agent, the only thing that we need to focus on is the planning part. Okay, is on the planning part. What happens in planning is, whenever you are given a task, how are you decomposing it? So when it comes to decomposition of your task, you have reflection, which is one of the prompt techniques. Then you have self-critic, you have chain of thoughts, and you also have something called as tree of thoughts, which we will talk in the upcoming slides. So planning and reasoning is where the actual research lies in when it comes to autonomous AI agent. And the last component is memory. So one memory is a very important part whenever you are building an agent. I'll tell you the reason. Now let's suppose we are going to any LLM, right? We are telling, hey, can you generate a Keras code? Now it will generate a code. This code, it is right or wrong, we don't know, right? Sometimes it might be right, sometimes it might be wrong. Most of the times LLM has given wrong code, right? How many of you have faced this? Right, so most of us know code what LLM is generated, it's wrong. So now let's imagine if there is a memory component which you will tell, hey, this code is wrong, this is the updated code. So next time whenever you are running the same code, you are getting the proper result instead of the previous response. So this is where memory is very useful, and there are two types of it. One is short-term memory, where you are just saving the previous buffer, your chat conversation or the task history. And then you have long-term memory. Based on your task, you are saving that particular conversation inside a vector database. So this is where we have a concept of retrieval augmented generation. So that, let me give you an example. If there are 100 conversations, do you think all the 100 conversations are important for your next task? No, right? Only few of them can be relevant. Out of 100, only 20 are relevant. How do we know those 20 are relevant? So this is where we have a concept of RAG, which will do the vector search and give you the relevant chunks of the data, which is required for your newer task. So this is how you implement the memory. So you have memory component, you have planning, you have tools and action. And this is the research work that has been conducted in the space of research. And what we will focus on is just the planning and reasoning part. And for reasoning, you have COT, zero-shot prompting. And then again, for planner, you have multiple tasks as well. So now what we will do is, we will talk one research at a time so that every one of us are on same page and we will have understanding of how to write prompts. Okay. Let's talk about prerequisite. So the first prerequisite is you need to know what is zero shot and few shot prompting. In zero shot prompting, you ask the direct question. If you want to know whatever information you need to get, you can ask the direct question. The second thing is you have few shot prompting. In few shot prompting, you're giving the context and then you're asking the question so that LLM don't hallucinate. It will give you the right response, right? So this trick is very important. All of us have used it once. I'll tell you an example. Whenever you're getting any error in the code, what do? You copy the code and you copy the error message and then you tell an LLM, hey, this is the code, this is the error, can you solve it? So what is happening now? You're giving that context, you're giving the code, you're giving the error message. That is the context, and then you're asking the user query. This is few shot prompting. Now that everyone are on same page with the prerequisite, let's talk about chain of thoughts. Chain of thought is a simple prompt techniques that help you to decompose your task into step-by-step solution. So we'll take an example here. I've taken two examples of Gemini and ChatGPT. So whenever I give a aptitude-based question, now what is happening is, look at the first line of code. It will tell, let's break down the steps to find out how many apples you have. This is from ChatGPT. Now if you look at Gemini, it tells, let's solve this step by step to find out how many apples you have remaining with. In both the cases, you have one keyword which is same, which is think step by step. So what you're instructing the LLM, no matter what the task is given to you, just think step by step. Whenever this comes into the picture, right, step by step, this means that you're using chain of thoughts prompting. Now there is a loophole, right? When we talk about chain of thought, you're thinking step by step. Whereas we humans know, each step can have multiple sub-steps. So you need to make a strategy, which step you need to pick. So this is where we have tree of thoughts. So what happens in tree of thoughts is, you are thinking step by step, but each step has multiple steps which you need to consider. So again, this is just a simple prompt. Now the question is, when do you use it? Whenever you just have to do a simple prompting for planning your task, you go with chain of thought. Whenever you want to make a strategy, for example, if you want to run any marketing campaign, there are multiple strategies that you need to take. So when it comes to strategy planning, go with tree of thoughts. That's it, simple. Now, I don't know how many of you noticed, there is one keyword above my slides which says agent without feedback, right? Now, if you notice, it is agent with feedback. So I'll tell you why I have added that. Whenever I give you a task, there are two parts. One is you plan. Second is you execute. Execution also matters a lot, right? Because we need better result. So far, whatever I have spoken, it's only on the planning front. Now we will talk about execution front, where you need to reason, right? This is where we have a prompt technique called React. It's also called as React agent. So the full form for React is reasoning and actioning. So you reason and you take the action. And there are three steps which are involved here. Whenever I give a task, first thing is it will think what it needs to do. Which one will think? The agent or an LLM will think what it needs to do. Second, based on that thought, what action it needs to pick. So remember the diagram what I said. You have set of tools. Based on that set of tools, you need to make a decision what action you need to pick. Now that you in this context is an LLM. So you have a thought. Based on that thought, LLM will pick which is the relevant tool I need to think, which is the action item. So if you notice here, it is telling search. In action 1, you have search. That means search is a tool. So the prompt is simple. I need to search Apple remote and find the program it was originally designed to interact with. So based on this thought, what it will do is it will think an action, and based on that action, it will generate an observation. Observation is where the decision making is happening. Your brain part is involved, which will think and reason, and it will give you the result. So in React prompting is where the actual humans comes in. Whenever we give a task, we repeat multiple things, which is like I give you a feedback, hey, this feature is not working well, can you fix it? So based on the feedback, you improve. This is what happens in React as well. You have thought, action, observation, it will repeat. Thought 2, action 2, observation 2. So whenever you have the better response, it will stop. So there are two ways you can stop it if you are building it from scratch. The first step is you can have maximum iteration. hey, this is the thought action observation, run it for 5 times, run it for 10 times. How many of you have heard of LangChain? Alright, so if you have used LangChain, in LangChain you have React agent, in that you have maximum iteration as one of the parameter, and then they also in their backend has output key. So now what this output key will decide is, whenever you have a better response, just return an output key which will tell this is the end of your execution. So this is one method where you can stop the execution of agents. If not, it will keep repeating. I'll give you an example of how to write a React prompt. You just need to focus on 4 things. One is mention the keywords, thought, action, observation. And the next thing is, no matter how many tools you have in your framework, let the agent know, hey, this is the set of tools that you need to pick. For example, you have given this, your available actions are tools str. So now, based on this information, you have whatever tools you need, and you are also giving few shot prompting. So what is few shot prompting? You are giving the context. You have the examples. And in the example, you can see you have question, you have thought, then you have action. This is the format that an agent needs to execute the code. So this is how the React prompting is written, and let's talk about it in detail. Probably since we have time constraint, I have created a video on it. If anyone is interested on how to build agent from scratch, you can probably utilize this particular video. And the link is bit.ly/React agent. Alright. So now let's talk about one advanced topic just for someone who wants to dive deep into agent. So far we spoke about, okay, React agent can think, it can act, and it can observation. But now the question is, observation there can be multiple. We humans have alternative solution, right? If this doesn't work, I'll go with this approach. If this doesn't work, I'll go with that approach. So the diversity of the response that we are getting are multiple. This is where LATs come in, which is language agent tree search. It's the same React prompt, the only thing is it adds the Monte Carlo search, which is one of the search technique which it utilizes, and based on that it will decide which observation is beneficial for your task. So it's same like React, but the only thing is multiple observation. So now let's build a demo so that we have some interactiveness. And in this demo, we will build multi-agent architecture using PyData. You have one web agent and you have one finance agent, and then we will interact with it. Alright, so as I already said, PyData is an open source framework which can help you build agent and also monitor your agentic system. They have few logs, history, and other things. And you can also ship your data using this open source tool. Alright, so this is a quick demo we'll look into. Probably I'll open my VS Code, and if anyone wants to follow along with me, you can also look at this code from your mobile. So you can open this QR code. It will redirect you to a cookbook which has the entire code. You just confirm if you are able to see the code. It should be roughly around 16 to 18 lines of code. Are you able to open a cookbook? Okay. I'll open my VS Code so that it's better to follow. Alright, so let's go step by step. In my initial talk, I said there are 3 components which we need to focus on. One is the LLM, second is the tool, third is the memory. Alright, so now since we are using this tool, what we need to do is we just have to import it. So the first statement is file.agent, import agent, and then you have an LLM. So OpenAI is the LLM that we are using. And for memory, we are using SQLite storage. So this is for memory. Since we are building multi-agent architecture, there are two tools involved. The first tool is DuckDuckGo tool. The second tool is Yahoo Finance. So if you are not heard of Yahoo Finance, suppose if you are from stock market, you want to gather information from stocks, you can use this Yahoo Finance. So these are the 2 tools. This is tool 1 and this is tool 2. And now what PyData also does is they have a playground where you can monitor both this agent that you are building, and you can also save your chat history so that you have a user interface to interact, not just running it in your CLI. So what we will do is we will run this code, we will run the server, and we will test this particular application on server. So in order to do this, we just have to import their playground. And once you import the playground, this is very important, you need to serve playground app. And I've already applied my API key in a separate file. So there is a file called API key. Inside that API key, I have my OpenAI API key. So I'm just importing it. Let me close it. Okay. So far what we have done is we have imported the statements, and the second step is we are setting up our OpenAI API key. So there are multiple LLMs that you can use. If you want to use open source LLMs, since not many of us has the access to OpenAI, you can use Hugging Face. There is Gemini, there is Together AI, there is Cohere. There are so many LLMs right now. Everyone are building LLMs. So you can use whichever LLMs you need. You can also build a custom LLM. And once that is done, you need to define an agent. So in agent, first thing is name an agent. Naming an agent, it can be straightforward. If you want to make it finance agent, web agent, co-pilot agent, anything. The next thing is you need to define an LLM. And here our LLM is OpenAI. OpenAI has multiple models. You have GPT, you have GPT 4o, GPT 4o mini. You can pick any LLM that you need. And then you have tools. Then you need to instruct what it needs to do. And based on that, you also need to provide a memory. For memory, we are using SQLite storage. And if you want to make, since we are using memory, make sure add history to message is true. This is very important. And whatever output format you need, you can decide that, mark down to be true. Same format, you are repeating to the finance agent as well. So instead of DuckDuckGo, you are using Yahoo Finance, and your instructions are different. So once you have defined two agents, you just have to run the playground. Inside playground, you have to define whatever agents you need, and then just run that particular inference. I'm using a VPN because when I was testing my application, it was giving me an error. So I converted into VPN to test out OpenAI. So I'll open this particular code. So once you have written this code, you probably have the cookbook. You just have to copy that cookbook as it is in your VS Code editor, and whatever the file name is. Suppose app.py is my file name, it should be same as it is here, app. So in my slides, if you see here, I have a finance agent. So whenever I am running this particular serve playground, I am making finance agent :app. So now I will just run a simple python.app, and it will give me a URL. This URL is where the PyData playground is running. I will just copy this. Okay. So here I asked a simple question. I am a cricket fan since I come from India, and this question was very simple. How much runs did India score in 4th T20 against South Africa? I'm also opening as a website which was approved. So as you can see the date, it is on November 15th, which happened yesterday. And then what I ask is, also tell Sanju Samson's score from yesterday's match. Now if you look at the response, you have India scored massive 283 for 1 in the 4th T20 against South Africa, and you have the score here, 283-1. How did you get the score? You got the score from DuckDuckGo search. And not just this, I will probably show you the history as well. Okay, it's not opening because of Wi-Fi issue. So I asked one more prompt using finance agent. What is the stock price of Microsoft today? And also can you give me some recommendation on how to invest? And this will create a plan for you. It will tell you the price and it will give you the recommendation using finance agent. So yeah, if anyone is interested in building agents, I'll probably touch base on what are the other tools you can build. Okay, this is visible, right? I won't do the slideshow. Okay, so one of the examples that we have built is code product documentation. It's like you have a GitHub code base. Based on that GitHub code base, you have this Gitbook, right? It will automatically create an entire documentation for you. For example, OpenAI is one library that I built on GitHub. So it's an open source framework. For that particular agent framework, whatever documentation you see, entire thing was written by an agent. Few parts we had human in a loop where we implemented it, but most of it was written by an agent. You just have to give GitHub as a tool and then generate it. Then you have assignment evaluator, like suppose if you want to hire someone and you have multiple assignments, then you can use an agent where your document is the tool that you can use. Then you have content creation. For content creation, you can use any web browser to do the SEO and then generate the results for you. And lastly, again, for market research, you can use the same web browser tool that you need. Yeah. So with this, thank you so much. And if you have any questions, we have 1 minute.
5.
5 minutes. Okay. So we have 5 minutes. Probably, if you have any questions, we can feel free to
Just,
Yeah, just go.
it might be an elementary question, but like my understanding of agents is that they leverage LLMs to execute things automatically. Is that correct?
Yeah. So LLM is the brain part of your agent, which will make the decision. So the planning and reasoning part that happens, right? That is where the LLM is used. So now, when it comes to agent, you also have to tell what tools, what actions you need to take. So the tools is external thing. You can have a simple function. So nowadays, even LLM has function calling, right?
So based on the finance model that you have, technically I can have an agent execute trade.
Correct. So
Automatically.
when, yeah, automatically.
So my actual question is how do you juggle the alignment question?
Alignment for?
So like agents have an alignment issue, right? Let's say if you ask it questions that are a little bit more obscure, a little bit more risky, how do you train it to be aligned to what you know?
Correct. So these days there is a library called TrueAI. So what they do is they have the training feature for an agent. So based on your task, you can train an agent, which is specific for that particular task itself. So that way you have a specialized agent itself because you have trained that particular model. So for training, you can have DPO mechanism. It's like fine tuning an agent. So there is one more thing. There is fire agent. So what fire agent does is it has a policy of saying you are training an agent using DPO technique. So now what happens in DPO is whenever you give a task, there are two parts. One is the successful answer page and one more is unsuccessful answer page. So now what it will do is it will use the successful answer page and then it will create an agent. So that way you are not hallucinating and you are sticking to the task that was given. Yeah, it's through AI and fire agent.
Can you spell it out? Can you spell it out? Because I was
Okay. True AI. I'm not sure if the Wi-Fi will work. It's CREW space AI and one more is fire agent. Fire and agent. Yeah.
Yeah, one more question about, can you explain a little bit more about the finance agent you demonstrate? So
Okay.
after they got the data from, say, Yahoo Finance, did they include in the prompt or how did they actually generate the natural response?
Okay, so when it comes to finance agent, right, whatever tools you use, you have to make sure that it gives you the right context.
Yeah.
Because there might be high chances LLM will just think out of the box and it will give you wrong false results. This is where tools integration needs to be accurate. There are two ways you can do it better. One is add your own document. If you are from finance industry, probably you might have multiple documents. You can build a custom tool which can fetch the proper result. If not, you can use the trustworthy websites. Finance Yahoo is one. If not, whichever stock market websites that you have for finance related, you can take them as a reference. So now what happens is, if you are building a custom tool, let's take you are building a custom tool for your own website. So you need to decide what output you need to provide to an agent. So this way, if you are building it from scratch, you have to have a doc string. So whenever you build a custom tool, right, you need to have a doc string which says what the tools does. Because in most of the agentic framework, you are giving these docs as a prompt. This prompt should be used when you are, that doc string needs to tell when you have to use that tool. So there are two. One thing is you need to have specific context that you need to return, and second thing is doc string. If you are building it from scratch.
The approach in agent programming about 15 years ago was to build expert knowledge systems and like planning techniques through the kind of knowledge base and world knowledge. Do you think that has come back in these systems, or do you think LLMs are a completely new approach and there's not a lot of value in the previous decades of research?
Okay, when it comes to LLMs, probably there are biased answers because sometimes people say LLM just hallucinate, it's not proper with the response. So probably I'll say it's biased in my opinion. Sometimes the previous response were also better. If you look at the 2018, right, the BERT model, you could have used it for question and answering, but nowadays people are using LLMs. It's just for the way you frame that particular sentence. It's mainly on how you reason. So that way we are currently better than previously, because previously you didn't have the reasoning capabilities. You could plan, but you couldn't reason. Even now, if you look at agents, right, you have multiple thoughts. So there is one research paper written by Apple which says LLM can't even reason, they can't even plan. The only thing is it can structure and design for you, but it can't completely reason. So they use something called as mathematical quotients. It's GSMK, it's the data set name for mathematical thing. So using that, they made sure that it doesn't plan and it doesn't reason. The only thing is it can design it. So this is how you need to do. But the execution part, it's still not up to the mark. This is where you have lags. Probably you will have multiple more things. So if transformers model change, most of the things will be fixed. Okay, I'll be here. We can take few more questions outside. Thank you.
Thank you.